Hello boys and girls, welcome to another episode of FoulkesBrau. Today on the bench we have one of these induction heater plate thingies, Snappy Chef thing. I'm sure we've done a video about this before. In case we haven't, we'll just do another quick run through. The parts have finally arrived, so let's take a look at it, let's see what's wrong, and let's repair this and get it out of the way. Alright, so here on the bench we have our control board for our Snappy Chef unit. Not really much to it, it's not a difficult piece of circuitry. Our AC mains come in here through our fuse. Obviously we've got a safety capacitor there. We've got some diodes in here and in here, and there's one there. Some big power resistors for current sensing and whatnot. 4-wave bridge rectifier. Little heat pad. You can see I've bent this IGBT down. In the first video, I'll show you how to test the IGBT. We picked up that the IGBT is gone, and the reason we picked that up is because the fuse is blown. So I'm going to just measure those and show you. The first thing that we would do, typically switch a multimeter once you've got everything out to continuity of diode, ideally diode. And you see if I short the leads out, we get a beep. And if I put it over the fuse, I don't get a beep, which I should get. So the fuse is blown. So if the fuse is blown, the first thing we're going to suspect is obviously power devices. IGBT, big mouthful, insulated gate, bipolar junction transistor. And what is it? It gives you the best of both worlds of a MOSFET, so it's easy to switch on, and the collector emitter voltage, the saturation voltage, is very low. Unlike a MOSFET, the source drain voltage drop is dependent on the RDS on value. With a transistor we have a saturation voltage, and this is very low. I think at 1200 volts they talk on this transistor specifically is 2.5 volts. So you can see between the collector emitter we've got a very low volt drop. I have desoldered the IGBT, so I'm just going to take it out and I'll show you how we test it. Again, simply, we've got our gate over here. We've got our collector and our emitter. If I measure between collector and emitter, I get a dead short, regardless of the body diode. There is a body diode in there, but I'm getting a short both ways. So that FET is gone. If we measure to the gate, to the emitter, short, gate to collector, short. So the IGBT is gone. Interestingly enough, they've put in a little diode over there, again across the gate, across the collector and the emitter. Although there's a body diode built in here, they've put another little diode in there. As I said, 4-wave bridge rectifier, safety capacitors. Okay, here's our output to our induction heater coil. Other than that, really not much to this. Down here will be our little switching device. So yes, really not much to it. So let's flip it over. We'll desolder the fuse, put in the new IGBT, and we'll put it all back together and see how it goes. Okay, the soldering iron is heated up. What I forgot to mention, obviously a nice big choke here to do with our filtering. Obviously the switching of this is going to make quite a lot of noise, so let's flip our board over. I'm going to take this device out, the fuse over here. Oh yes, okay, so let me just lock the so basically you want to take out that pad and that bit of solder there, not the pad. You really don't want to take the pad out. So to make it easy, as usual, I'm going to use my flux paste. Just take a bit of a toothpick. We'll try and do this around the camera. I just use a toothpick, dab it in. You don't really need that much, but depends how much you want to clean. And I'm going to put it over there and over there. I just find that the flux paste makes everything so much easier to desolder and work with. So I'm going to do this around, I'll try and do this around the camera. Let's just see that the focus is in good. I'm cleaning my soldering iron tip. Obviously we don't want to knock anything. So I'm just using my handhold solder pump. Let's try and do this on the camera. There we go. Nice and easy. Fairly easy. I did get the right pad. And that's pretty much it. Our fuse dropped right out. What I'm going to do is put my soldering iron back. But before we do that, always remember, put a little bit of solder on the tip. I'm going to try and do that behind the camera. You just want to tin it just to protect it. You don't want oxidation and things to kill it. So the fuse that was in here, let's see if we can get a, you can see that's nice and shut. Okay, so it's not a ceramic fuse. They put this little bit of fiber over it to hold it so that when it blows it doesn't shatter and come out. So let's see what rating is this fuse. Okay, so it's a 10 amp fuse. I do have, let's see if I got it. What have I got here? Okay, I've got 10 amp. I have 10 amp fuses, but mine are ceramic, which is fine. I prefer the ceramic fuses for this. So let me just open the packet. So I'm going to replace it with a 10 amp ceramic fuse. Of course, obviously, you want to check that the fuse is fine before you put it in. Even though I do trust these that just come out a brand new packet, but you never know. So we'll just check it. All I'm doing is I'm measuring it off the camera like that, so you can see the fuse is fine. So we'll take the fuse. Let's just bend the legs. I'm not going to put the ceramic. This is a ceramic. We'll just put the fiber back. Pop the fuse in. Just bend the legs out like so. Just to hold it in place for you to solder. Okay, let's get our soldering iron. Now we'll just do the reverse of what we did before. Trying not to get the soldering iron lead. So I'm going to put it like that if you don't mind. It's just easier for me to solder. Very easy. Tip on one side, solder on the other, and just let it flow. Pull the solder away and pull the tip away. Same thing on this side. Flow your solder, let it settle, pull the tip away. Nothing difficult about soldering. Okay, so now we've done that, take your side clippers, hold, don't cut too right on the solder mound, just cut at an angle and leave a little bit, and of course ideally hold the lead, because this stuff does have a tendency to shoot. There we go. Okay, perfect. What I'm going to do is I'm just going to solder in the FET quickly, or the IGBT, and then we'll come back. So there we have our IGBT in, and I thought we'll just try and solder it from behind the camera. Shouldn't be too much of a headache. We'll try. Again, I've just put a bit of solder flux down. So let your solder flow, then remove the tip. Same for the middle pin. Flow the solder, remove the tip. And that one left a little bit of a hole, we don't want that. Flow the solder, remove the tip. And that's about it. It doesn't look too bad. No, not at all. Maybe a little bit more. Yeah, it looks fine from where I'm standing. Of course, these IGBTs are carrying a big power. This is a 50 amp rated one. I will come back and clean that up after I've bent the legs properly. Right, so that's that. Of course, let me turn the board over. This IGBT bends over onto that heat pad. So I'm going to just put a bit of some thermal compound on there, and then I'll bend it over. And the way I put the thermal compound on is I use a toothpick again. Again, you don't need lots of it. The more you put on, the worse. You just want a very, very thin coat. It's just there to aid heat transfer. So too much and you will have problems. So you really want it very, very thin. But of course you want it consistent. Yeah, you can see that. So that's fine. So not too much. There we go. Okay, perfect. So I'll bend that over. We'll remount this board off the camera. One thing we should check while we're here is that we don't have any short. Again, I'm going to just put it to diode. We'll measure across the live and neutral. Nothing. Good. Our fuse is fine. Again, across live and neutral, just swapping, no short. And if I measure the resistance, good. We've got a whole, well, as the capacitors are charging, roughly 3 mega ohms, so that's fine. I have checked the bridge rectifier again. Very simple. Switch it to diode. We don't know which leg is which, but I presume these two inner legs are AC. So no short. A diode beep. So we've got, that's fine. A diode. No short, that's fine. A diode. That's fine, a diode. So a diode to there, a diode to there. Perfect. So our bridge rectifier is fine. So I'll bend this over, put it back together, and we can come back and see. We'll switch it on together. Alright, so I've put our Snappy Chef thing back together. You can see I haven't screwed it in. I can lift the whole top off. So the moment we've been waiting for. You can see I haven't plugged it in yet. So let us do that together. Off. Oh well, it switches on. It did something. Right, so I'm not really sure how this thing works. What I do have is a excuse me, a pot with some water. So I don't know. I'll wear them on. Oh well, it's doing something. Okay. And it gives me an E0. I wonder what E0 is. Luckily I've downloaded the manual. What the hell is... incorrect cookware. Okay. How the hell would I... Okay, well at least it's not IGBT. Okay, error codes, E0. See when I switch it on. If you watch here, it tries to fire and I get an E0. So the error codes for this thing: E0, no cookware, incorrect cookware. Ensure your cookware is compatible with induction appliances. Okay, so I don't know what cookware I need for it. Interesting. E1, the IGBT is overheated. E2, the heat sensor is faulty. E3, the supply voltage is too high. E4, supply voltage too low. E5, overheating in general appliance. E6, induction intensity is too low. E9, internal loose connection. Okay, so it looks like this thing's fixed. I wouldn't know what the correct cookware for it is. So, yeah, I'm going to call that a success. So what we'll do is we'll set up for the final shot and I'll get you there. Right, that brings us to the end of another repair video. Not much to it. There's not really much inside a Snappy Chef induction heater. So the inductive coil creates a magnetic field, and that's what's doing it for you. Obviously with the cookware that you are using. So there's got to be two parts, and I obviously don't have the right cookware for it. It switches on. It tries to do its thing and picks up that it's not getting the right stuff. So clearly, what can I say about it? Yeah, not much in it, not much that can go wrong. Fuse, IGBT. As always, I hope you had fun, I hope you learned something, and till the next one, take care, cheers.